before class assignment number 19, bearings. To get 10 points for this assignment, watch the following videos. This video discussing BC-19 and different types of bearings, and also a video showing how ball bearings are made. After you've watched those videos, determine the vendor and part number for the following components that will be used on the gang drill and obtain CAD models of each one. The precision linear shaft with support rail. It's 5/8 diameter, 24 inches long. A pillow block housed ball bearing for a 3/4 shaft. It's a self-aligning bearing, 1 5/16 center height. And a pillow block housed linear bearing, an open style for a 5/8 inch shaft, self-aligning. Now let's go ahead and talk a little bit about bearings. There are several different types of rotational bearings. Probably the main one most of you are familiar with are ball bearings. The inner race, the cage, the ball, and an outer race. Ball bearings are good for radial loads, but very poor for thrust loads. Another type of bearing is a roller bearing. These are excellent for radial loads and bad for thrust loads. There are also needle bearings. These are also excellent for radial loads, but poor for thrust loads. There are thrust bearings that are pretty bad for radial loads, but excellent for thrust loads. There are tapered roller bearings, and there's a single taper or even a double taper, and these are good for radial and also good for thrust loads. There are also plain sleeve bearings, which may have a little more friction, but they are good for radial loads and good for thrust loads. Here are some types of bearing housings. One is called a pillow block. There's also another type of pillow block, which is a tapped base. It's a little bit more small and compact. There are 2-bolt flange bearings. There are also 4-bolt flange bearings. There's a take-up housing. These are usually used on conveyors where you need to tension the pulley and tighten the conveyor belt. There are also cam follower bearings. And please also note that you could also build your own custom bearing housing. Let's talk about the need for self-aligning bearings. You can buy these housed bearings that are self-aligning. Self-aligning means that the bearing can pivot in the housing. It's quite difficult to make sure that your bearings are perfectly aligned. So if your bearing is not aligned and the bearing cannot pivot in the housing, the shaft is going to bend and fatigue. That's bad. But if the bearing can pivot in the housing, the shaft can stay straight. That is good. So since it's so very difficult to make sure your bearings are perfectly aligned, 2 bearing designs are the most common because they allow the shaft to stay straight. That's good. 3 bearing designs, they will cause the shaft to bend. Because if 3 bearings are not aligned with each other, even if they're self-aligning, the shaft will still have to bend to get through the 3 bearings. So that's bad. 3 bearing designs are usually bad. Now let's talk about linear bearings. Here are some different types of linear bearings. There's some linear bearings that mount to round rails. Here's an example of an end-supported shaft with a closed bearing. Here's an example of a continuously supported shaft that would use an open bearing. The bearing would have to be open to provide clearance for that continually supporting member. These bearings are in housings. There's a closed pillow block housing. Here's an open pillow block housing. Here's a closed flange mount housing. And the bearing that goes in those housings could either be a reciprocating ball bearing insert or a plain bearing insert. And those plain bearings could be lined with Teflon or Freelon or bronze. Here's another type of linear bearing. It's called a Versa mount. There's also track mount linear bearings and even external wheel mount linear bearings. Here are some rotational bearing vendors, brands, and distributors, as well as linear bearing vendors, brands, and distributors. Okay, let's go ahead and download some of these CAD models. Okay, first I'm going to go to McMaster-Carr, master.com, and let's look under bearings. I'm going to get a mounted bearing, a ball bearing in a housing, and we'll do the base mount, or they call that the pillow block mount, a solid pillow block. And let's do a ball bearing, and we need this for a 3/4 inch shaft, and we want the 1 5/16 center height. Here are some different bearings. We might as well get the cheapest, which is this $26 bearing, and it looks like there's a CAD model available, so we're lucky. Let's download this CAD model in step format. I'm going to call this a pillow block ball bearing for a 3/4 shaft. McMaster part number. We'll save that. Okay, now let's get a linear bearing. See if they have linear bearings here available at McMaster Car. Look, there are some good linear bearings, both inserts as well as housed bearings. And we're going to want the open style because we want the continuously supported rail. So let's look at some of the options. We'll find some housed linear bearings. There's the housing, but it doesn't have the linear bearing in the housing. So we're getting closer. Here's some housed linear bearings. We want it for a 5/8 shaft, $85 each. That's pretty pricey, but it's the price you pay for precision. And this is a closed bearing. We actually want an open bearing, which is a little more expensive yet, $103.37 for a 5/8 shaft. Now here's something that's maybe a little cheaper, a $90 bearing that's single length open 5/8. Let's go to this page 1074. Looks like here's some closed bearings and some open bearings for a 5/8 shaft. This one's $53. That's a little less expensive. Here's some heavy duty that are more expensive. Page 1075 is now flanged bearings. So back on 1074, it looks like the most inexpensive one I can find that's open 5/8 shaft is this one here that's $53. Great, we have a CAD model. Let's download that as a step file, and we will call this a pillow block open linear bearing for a 5/8 shaft. McMaster part number. We'll save. Now all we need is the rail. So let's look at linear shafts. And we want shaft with a support rail. Let's do the two-piece. We want a 5/8 diameter, 24-inch long. It looks like we have two options, a steel and a stainless steel. Let's go with the less expensive, $158 for one of those. It better be precision. Look at the tolerance. The diameter tolerance is less than 1/1000th. But notice there are no CAD models available for me to download. So this one I'm going to have to model myself. So I'm going to take a note of some of these key dimensions. Dimension D is 1 5/8 wide. Dimension C is the hole spacing, which is 1 1/8. Dimension A is the center height, which is also 1 1/8. The distance back to the first hole is E, it's 2 inches. And then the hole spacing is 4 inches. And the rest of it I might just have to make up. So let's do a new part. And let's, first off, let's draw our 5/8 circle. 5/8 of an inch, and we know a center height, so I'm going to project geometry, both the datums, and let's specify a center height of 1 1/8. And we'll place the center of that on this datum. We're fully constrained. So now I'm going to go ahead and extrude this by 24 inches. Now let's create another sketch on this same plane. And I'm going to project that geometry. We'll create an arc. And I'm going to make this arc concentric with this one, and we'll also make it equal radius. And then we'll just start drawing some of this. Okay, now we'll put some constraints. Let's make those equal length. We'll also make these equal length. We'll make those equal length. And we'll make those equal length. Let's project some geometry. And we'll place this line on our datum. Now let's give it some dimensions. We know this is 1 5/8 wide. This is something we're going to have to guess at, this length here. So let's make that, should we say 1/2 inch? And I'm also going to place the midpoint. We'll project this datum and we'll place the midpoint on that datum. So we've got our symmetry. We're going to have to make a guess on this thickness as well. I'm just going to do what looks right. 3/16 of an inch looks about right. We'll place a dimension here. Let's call that about 3.125, about 5/16 of an inch. That looks about right. And let's give this an angle that looks about right. Should we call that 60 degrees? That looks about right. Okay, so let's finish our sketch. I'm fully constrained, so I can finish the sketch. And let's extrude this. Now, since this is a different part, I'm going to extrude it, but I'm going to be making new solid as I extrude. I don't want it to join to the existing. And I'm going to go up into the end of this shaft. So I want my support rail to be that same length. Okay, so there's my support rail. Now let's put some holes on it. I'm going to do a sketch on this bottom face. And I'll place 2 points. I'm going to place 2 points that I'm going to put holes on, and we'll project some geometry. I'm going to draw a line between those 2 points, and I'm going to place the midpoint of that line on the center to capture symmetry. And I'm going to move those points down here. Let's also project this datum here and specify that the distance to the first point is 2 inches, and the width of those holes is 1 1/8. We'll finish that sketch. Now let's put our holes at those 2 points. Now I forget if it tells us what size the holes are. Let's go back and look. G is the hole size, which is a 0.190. So let's specify that it's a 0.190 diameter, and we'll tell the hole to go through all. So now I have those holes. Now I'm going to go ahead and do a rectangular array, and let's choose those holes to pattern, and we'll tell it to be this direction, and we want to be 4 inches apart, and we're going to need, I'm going to say 1, 2, 3, 4, 5 sets of those holes, maybe even 6 sets. There we go, that looks right. Okay, so now I've got my rail modeled, and it's as close as possible to the real thing. At least I captured all the dimensions I possibly could from the catalog. So now let's go ahead and save. We'll save as, we'll call this a linear shaft and support rail. 5/8 diameter by 24 long. McMaster part number, and then we'll go back to McMaster and copy this part number and paste it into our file name, and we'll hit save. Okay, now we've got CAD models of each of those components that we're going to use on the gang drill, and that concludes this before class assignment. We'll see you in class.